Welcome to this session on infrastructure of DevOps, the Azure Stack and containers. My name is Damien Flynn. I'm an MVP on System Center and I blog at damienflynn.com or can be found online with my Twitter handle at Damien_Flynn. My focus is on the IT pro side of the house, so it's an honor for me to be here today to talk about DevOps. I focus in on a lot of the Azure technologies, System Center in the data center, and of course, automation and DevOps, trying to understand how we can join together the powers of the development, the network, the storage, and the compute that is the IT pro side of the world. In this session today, we're going to spend some time talking about the new service offerings that are included as part of Windows Server 2016. The first of those major new investments is that for containers. We're going to talk a little bit about what containers are, how we can use them, and how they fit into the DevOps story. We'll also take a look at the Azure and Azure Stack resources. Part of the investment in 2016 is the delivery of Azure Stack, which really is simply Azure, but in a locale that happens to be your data center. Why is this relevant to us? This, along with containers, is going to help us understand how to get to our third point, which is essentially infrastructure as code. We're going to spend some time taking a look at what it looks like to write infrastructure as code using what is known as resource manager templates. These are JSON templates that essentially depict precisely what it is we want in our infrastructure. But because this is as code, we can do all of the normal dev processes, including keeping this as part of our version repositories and including this in our release cycles. So when our developed applications are ready to be deployed through the different environments of quality, validation, and production, we can also ensure that a consistent infrastructure is part of that recipe. This is an online session, and throughout the whole presentation, we have a team supporting lots of questions. So please feel free to ensure that you tweet or ping us through the question and answers windows, and we'll do our best to try and address your questions either during the session or after the session. Thank you for joining us today, and let's get started. So before we start digging really into how we write our infrastructure, we're first going to spend a little bit of time to understand what we're writing to. What are the technologies, the targets that we're actually going to involve ourselves with, and how do they work? The first of these is Windows Containers. Windows Containers is based on the proven Docker technology that is prolific across the Linux world. With Windows Server 2016, Microsoft, in cooperation and collaboration with Docker, have essentially enabled us to deliver Windows Server Containers. Now, why do we care about Windows Server Containers and what do they offer? Well, they offer us a consistent build process that allows us to build our modular applications. And because these applications are essentially built in models or in services, we can scale them and do this work independently of each of the other tiers that's going on in the environment and at the cadence that supports your sprints. No longer will we be in a scenario where we can have lots of agile sprints writing our development code only to run into a queue when we've asked for deployments or require IT to provision new infrastructure to support this. With containers, we effectively hand off a container that has a consistent operating system and set of binaries for our applications. So we are also going to have that level of confidence in that the container that we are delivering to IT will run. We're not going to be scratching our head saying it runs on my development box, but it isn't running in production, and having all of those challenging discussions between IT asking to get provisioning access to the machine to understand what's going on, listing off the different DLLs, the dependencies, and then finally realize that we have a different version of .NET running on the production server and IT decided to co-host your service on a server that has a non-compatible service sitting there. Containers does away with all of these and allows us also to be in a scenario where we can actually get our development teams up and running in a matter of moments. Having a container with all of the different tools that are necessary for us to do our builds, get our environments into place, allows the teams to scale between the different projects or on-ramp new engineers into the group as fast as possible. Running these containers is something that is built into the core of Windows Server 2016. It offers a Docker runtime, which essentially will take those containers and allow us to use either PowerShell or Docker commands. So if you are already using Docker and have experience from the Linux world, then you're going to have a consistent experience as you start moving into Windows and continue to use your Docker commandlets for managing all of your different containers and images that you're going to run in your Docker world. Now we do still have a dependency on PowerShell, and this is really just from the server backend. So as we actually need to do additional tweaking or advanced configuration, then we will utilize the shell for managing the actual backend or the OS server. Just like Docker and Linux, we have resource management and resource governance. From here, we can control the amount of CPU that we're going to offer to specific containers, the memory, storage, and network IOP profiles. So in allowing us to make some decisions, and from an IT perspective, allowing us to make sure that we don't have noisy neighbors blocking down containers to ensure that they are behaving correctly, and allowing us to get as many containers onto a host as possible. In addition to this, as you'll see a little bit later, we have a very special operating system image for sitting inside our container, which essentially is Microsoft's brand new Windows Nano server. Now, Nano server effectively is a subset of the actual Windows OS that we see today, which is Windows Core or Windows with a desktop. But Nano effectively has ripped out all of the additional DLLs that are not required when we start running our hosts, and are running copies of .NET and IIS and a lot of those additional services that we need to actually host our applications. From a networking perspective, the containers are just like their first-class cousins over in the Linux world, having NAT and different types of bridging technologies allowing each container to communicate with each other. However, in Windows Server, these network interfaces are connected directly to the HyperV switch. Now, while that may not sound important, it does allow us to leverage software-defined networking and build far more advanced scenarios than we can currently in our default Linux environments, embracing the new VXLAN technologies and all of the different benefits that are offered to the Hyper-V switch. Now, Microsoft have gone a step further and have introduced a second type container. Now, this second type container has some additional benefits, but first things first, it's very important to understand that these containers are consistent. They follow exactly the same APIs as the Windows Server containers. They're compatible in that the images are exactly the same, so you can make a decision to deploy it as a Windows Server or a Hyper-V container. And the real difference here is isolation. In the Hyper-V container, every container has a dedicated kernel instance. It's got a dedicated OS sitting under its application binaries. In the Windows Server container, just like in Linux, we're using shared binaries. So essentially, it is one OS with all the shared binaries and a shared kernel, which is speaking then to the application. In the Hyper-V container, that is isolated, keeping any suspected, or if we've got very sensitive environments, then we can leverage this Hyper-V container technology. It's built on our true and trusted Hyper-V, so all of the isolation benefits that you get in Hyper-V exist right here in these containers. And of course, again, you're not going to hit a performance issues leveraging this container technology, as the operating systems and the hypervisor have been fully optimized to ensure that the performance and the startup time of these containers is as fast as we'd expect from even the standard Windows Server containers. Now, with two different types of containers at hand, really, because of the consistency, management of these will remain essentially the same. We will use the different orchestration and management tools. Of course, PowerShell with a brand new module for our containers. That PowerShell will talk to the Windows Management Instrumentation environment, which in turn talks to the VM Management Service. VM Management Service then is responsible for actually doing the final communications downstream. On the other hand, if you've come with experience from Docker or you want to be using the Docker client, then that moves forward and communicates with a REST endpoint. A REST endpoint, of course, then makes us communicate with the Docker engine. And just like the VM management service, both of those endpoints communicate directly to the service layer, the container functionalities that are sitting inside our brand new Windows OS. And that enables us to turn on both the host compute and the host networking services. Now, behind all of this, we really have to think about, why do I care? What is this going to do for me as a developer? So the concepts are quite simple. As developers, our objective is essentially to work with IT and enable us to take our projects and deliver them in a repeatable, consistent manner. You're going to continue writing using your friendly tools, including Visual Studio, and you're going to ultimately build a package that gets dropped to a central repository. That repository can be a file share or a Docker repo. And from there, the IT operations guys are going to monitor that file or repository and publish your image up to their production servers. That allows the IT operations guys to monitor and do all of the normal things they need to do to ensure that we have the security and the feedback in place. But more important, also allows the IT operations to communicate with you, show you the information and the performance, allow you to do the tweaks that are necessary, and ultimately you can then continue your life cycle as you update and iterate through the different versions of your applications, making tweaks and repackage them into containers that ultimately get delivered back into the repository, and from there back out into the actual live production servers, keeping a very simple, consistent environment. And because at the start we mentioned that this whole ability of containers allows us to do this at a cadence that is affecting only our requirements, and because we have broke our applications into separate services, we can swap these in and out as necessary, rolling back, rolling forward, or whatever different methodologies you're utilizing in your development environment. Now, the other side of the coin is Azure and Azure Stack. So let's take a few minutes and we'll take a look at what this has to offer for us. So at the very heart of Azure, we have essentially the Resource Manager. Now, regardless if we're targeting Azure or Azure Stack, the Resource Manager is going to offer us a number of features or benefits. Those we would call artifacts. For example, the first things that we get offered is the concept of resource groups. It allows us essentially to group lots of like or related resources that are important to our application or to our service that we're providing. That group contains providers, and those providers will define the artifacts that essentially help us deliver the infrastructure that our application runs on. That could be a network interface or a computer, a virtual machine, a database, a website. And all of those artifacts are defined and written out as infrastructure code in a format known as JSON. We'll take a closer look at what those JSON templates look like in a short while. Now, we also have an ability to tag these resources, either the resource or the resource group, helping us essentially to organize these depending on how our environment requires. That might be per environment, it might be per build, it could be for the color or the day of the week or the month or the size of the moon. Tagging is ultimately up to you and how you run your environments. Access control is built right into the middle of the environment, giving us full RBAC, allowing us to make decisions on who can touch the resource or the resource group, and the level of touch they're allowed to do, from view to none to full control, and that's quite granular. And ultimately we have one more feature, which is the ability to deliver policies. Now, these policies are really in enforcement. They allow us to define that as we deliver the template to the resource manager, we want to enforce that the naming standards have met the conventions that have been laid down by IT, or that we are deploying this to the correct instance or the correct location if we happen to have more than one location. And again, as I mentioned, Azure Stack and Azure as a whole are effectively the same. All we are looking at is different locations or a different set of providers. Azure Stack, in its current technical preview, has a very limited number of providers: compute, storage, network, MySQL databases, SQL Server databases, and web applications. Where if we look at the Azure service, it's obviously got hundreds more, including media services, notification services. So over time, as Azure Pack moves out of technical preview and the Azure Stack gets more and more resources, then those policies will come into play and allowing us to make additional deployments to that environment. Now, this resource manager is actually very, very important. It is what defines Azure and what makes Azure essentially special. And within the core of that environment, we essentially have the resource manager looking over everything that's happening in the environment. From a security perspective, this is quite an interesting scenario because as we work in dev and IT and get the DevOps security environments into place, one of the major pieces that we're going to start leveraging is the idea of subscribing to resources from that fabric. And each of these subscriptions become boundaries. That subscription might be from different product teams, it might be from different project teams, it might be from different divisions in the organization, or if I happen to be a hoster, then these might be different tenants coming from the outside that are subscribing to our resources. Really and truly, this is quite flexible. Now within each subscription, we then can split that subscription further down into resource groups. Those resource groups, as we just talked about, allows us to actually group numbers of different types of resources together. So for example, our storage could be all in one resource group, our compute could be in a separate resource group. Or we may make a decision that we want to actually host our application QA deployment in one resource group and our production in a separate resource group in a separate subscription, and utilize these for different boundaries of security or access control. Now, one of the things that's common to all the resource groups is the ability to tag them and assign their local access control. Or we can do the same down to the resource level. So we may get to that point where we are actually deploying our full solution into one resource group, but making some very strong decisions based on security policies that are maybe appropriate to us due to SOX, FIPA, or any of the other compliances that are necessary to ensure that specific users cannot touch a specific resource. In this case, then we have that ability through the resource manager to lock down and prevent anybody unauthorized, and it is audited, so we can actually come back and check and see has any attempted breaches been applied to the environment. Now, in addition to the security of the resource manager, it has to run a pretty complicated process to actually do the deployments. We're going to hand it a template, and that template is going to define effectively our recipe for building the infrastructure that we need to effectively deliver our application. Now that template has to get checked, and the very first thing the resource manager do is validate to make sure that there are no errors in the JSON file, and if there are, it will abort and tell us that we need to go back and reiterate on the code. The second check is to ensure that we actually have the privileges to deploy all of the different resources, or if we're targeting our Azure Stack, to ensure that all of the resource providers that are necessary exist. If they don't, again, the system will abort and inform us that we need to go and take a check on the code or retarget it to a different location. If, however, we pass that check, then the resource manager is going to double check and ensure that we have storage resources that are going to be necessary to host the artifacts of our application, the virtual disks for our service, and once those have been provisioned, we can move forward and start looking at the network. Now, in a similar manner, the resource manager will actually move forward and communicate with the network resources. Now it's important to identify that both in storage and in network and in the compute we look at in a moment, these are all software defined. In the Azure Stack and Azure world, everything that we deliver from this point forward is essentially delivered as software-based services. So the concept of the Azure Stack talking to the SAN in order to split off a LUN at a technical level isn't the case in the TP1 preview. We are communicating directly to a Microsoft storage spaces, and at that point the stack will actually spin out pools from that space specifically for us to work in a blob. In a networking perspective, it is quite similar. Azure Stack is not trying to make a connection to your core switch infrastructure in your data center. Instead, we have this concept of a network controller, and this network controller will communicate with all of the hosts that are hosting our virtual load and allow us to define and create and route software-defined networks specifically for these workloads. When all of those have been put into place and everything is ready, then the resource manager will kick in the compute placement process. Now that really takes a quick look at the actual cluster and check to see, first off, where are our hosts in the environment. From the cluster, we can get information of which of those hosts are loaded or unloaded, as the case may be, with different workloads. And then, of course, check for availability sets to help us make sure that as we define this infrastructure, we are keeping conscious of the fact that we want no single point of failure. And during patching and servicing, we have our nodes deployed in highly availability sets to make sure that we're addressing those. Once that we have figured out where we're going to do the placement, we'll provision. And the compute controller will reach out and actually communicate with that host that has been identified as the appropriate location for deploying our virtual machine, which in turn will move forward and communicate with the actual storage that was created a little bit earlier, referencing the images that we are storing in what we call the platform image repository. Now these images happen to be similar to what we looked at with the idea of containers, where we have that base operating system. Those images are probably serviced by our IT team once every month or so to make sure that they're updated with the most relevant patches, and utilize things from a function known as the extension manager, whose job essentially is to make sure that once those images are prepped and ready for deployment, that it will hook them up and wire them into the environment for us. Now that also allows us to attach the network. So now that we have a virtual machine essentially provisioned, the disks are in place, the network controller is now attached, so the virtual network interface gets connected to the network that was established a few moments earlier. Or in the case that there's an additional deployment to an existing network, then it simply will wire it up, and then we can go. The controller now starts the new virtual machine, and once that virtual machine has been started, it gets effectively an Azure agent pushed into it. Now the Azure agent is going to do simple things like making sure that the machine has a valid computer name, because during the deployment we've made a decision that we want this machine to be named in a specific way. It will check to make sure that we have an IP address and place that IP address on the machine, and just do OS level configurations to make sure that this machine is in place. Now the agent is agnostic. There are versions of it for Windows or for Linux, so really we don't mind what our host in the background is going to be running. After that, the OS profile will get deployed, and that profile will allow us to do fine tunings on some of the features that we want within the actual OS. And that again is done by attaching an ISO to the machine. So if there are specific things like setting up the administrator passwords and the features that are done during OS deployments, then the resource manager is going to take care of this during this initial boot of our virtual machine. Now at this final stage, the resource manager is going to start injecting extensions. Now these extensions are amazing. They allow us to do a plethora load of new configuration options. Extensions essentially get injected into the virtual machine, and those extensions will then reach out and add more functionality to that base machine. This allows us to get that consistency that we need. So for example, if we have a requirement that we always have an antivirus, then one of the extensions we push out may be that antivirus extension, which calls home to the actual central server and registers the instance with that server. On the other hand, given the fact that we are going to be deploying applications, then this may be a scripting engine So the extension might actually run a specific script that we've actually stored in our repository. Then that script is responsible for actually doing host configurations and implementing our application. Or it may be desired state. It could be Octopus, Chef, or Microsoft's own DSC. And these extensions will then again reach out to your DSC scripts and run your defined configurations for what is necessary in order for the resource manager to ensure that when we're finished, that this deployment is correct and following the infrastructure as code definitions that we have built. At the end, the system will simply just check, make sure that we have all of those things pulled in, and then hand you back a virtual machine to say, congratulations, you've been deployed, and you are now following a full infrastructure as code environment. Now the process is complicated, and the flow here is based on what we have currently in TP1. This flow will probably change over the course, but the concept behind reading that JSON file, which essentially depicts what infrastructure as code really is, that won't change. That will be consistent and will remain consistent. The steps behind the scenes, how the stack implements all of this stuff, as we move through different technical previews, these steps will of course evolve. They'll become more fine-tuned. Some of these will be run in parallel. There'll be many changes happening as the system runs through these environments. So that effectively covers our two major scenarios for delivering infrastructure as code. We have containers based on Docker technology and allowing us to use a Docker file depicting the OS, and then a set of steps, instructions that are used effectively for defining what it is that we're going to deliver in these containers. Containers are then handed off to our IT guys from a repository who are then responsible for making sure that we deliver these containers to the production environment at a true sprint cadence. The alternative option is to leverage the Azure Resource Manager technologies, either in the cloud using Microsoft's Azure or on-premise with your own version of Azure through the Azure Stack, and following effectively the use of infrastructure as code based on a JSON template to tell Azure how to build out the environment. Now, one big advantage on using the Azure approach is that unlike the Docker configuration, where it is restricted really to the container and the connectivity from that container to the network, we can go much further with the infrastructure as code in Azure. We can talk about things like load balancers, network firewalls, different subnets, and all of these type advanced configurations. So from an Azure perspective, the infrastructure as code allows us to get much further down that journey to where we're ultimately heading to. Now for the next portion of the presentation, I'm going to actually jump out of the presentation deck and over onto a server, and we'll take a look at what the JSON file looks like. We'll spin up a copy of Visual Studio, and then we'll take a look at how we might actually integrate this into our deployment process. Okay, now I'm logged on to my workstation and I've just hit the landing page for Azure Stack. Authentication for Azure Stack is hosted on Azure using Azure Active Directory, and I have essentially two accounts. I have an administrator who has full access to the stack, and then I have a tenant whom I'm going to log in at the moment as. So just provide my credentials, and this then should allow the actual stack its default instance and offerings for me. So you can see that in my environment I already have a POC, a virtual machine, deployed with an IP address. It's hooked up to a network interface, security group controlling things like network. So as we browse around the configuration, this you will start to feel is exactly the same as what we have in our public Azure, because Azure Stack is Azure, as we keep saying. Here I can see my actual resource group that I deployed a little bit earlier on. And inside that resource group, I can actually see that list of resources one more time. And picking any one of those resources, I get the same Ibiza portal or blade effect that is essentially offered in the public Azure. Now, one slight difference, obviously, in a proof of concept, the public IP addresses that are offered inside our Azure Stack are actually private addresses. But again, technical preview, this will change as we move forward. Now, I'm going to leave the Azure Stack alone for a moment, and let's jump over and take a look at the tooling that we're going to leverage. And this, of course, is going to be Visual Studio. I've added to my Visual Studio instance a new SDK, and this is the Azure Cloud SDK, and I'm running version 2.9. Now that introduces us a concept of a Cloud Explorer, which is an extension to the Visual Studio IDE, offering us the ability to look at the different resources that we have in Azure sitting behind the resource managers. In this scenario, he's actually asking me to make a connection to my Azure instance. Now that I'm providing my credentials, I'm going to identify myself, which will allow Visual Studio to communicate with Azure Active Directory and find what instances of Azure I have actually got subscription connections to. Now this happens very quickly, and I can see that the Cloud Explorer has actually gone ahead and refreshed itself. Now what we didn't see happening in the background is that the Cloud Explorer has actually connected me directly back to that same Azure Stack environment that we just looked at a moment ago. As I start scanning through these, I can see all of the exact same resources we looked at in the Stack view. Now this is quite important because, again, this consistency message, Azure Stack is Azure, is playing straight through for us here, where we can see that the Cloud Explorer simply looks to see what Azure subscriptions I have, and given the fact that I only have the one associated to this particular account, that's the one that's rendered up, and regardless of it is in the public cloud or on my private cloud. Okay, now, as part of our DevOps objective, basically we want to define the infrastructure that we're going to deliver our solutions in as part of our project. And to do that, I'm actually utilizing the extension from the SDK so that I can actually load up the Azure Resource Group definition. Now, as I don't have an existing project, I'm just going to simply set up a new project and solution, which I'm not going to add to source control. We'll do that in a moment. So now the wizard comes back and offers me a selection of templates. Now I can choose from a blank one and start with a 0, or I can take a predefined template that actually will help me to get started with what I'm trying to deliver. So for example, in this particular case, I could say I would like to use a Windows Server virtual machine and enable some load balancers. So let's select that one, and we'll watch as Visual Studio spins up our new project. And under the project, I can now see that I essentially have templates. The templates are delivered as two files, a JSON file for the actual infrastructure as code, and then a second file which will provide the parameters that will be unique for each instance of our deployment. So to take a closer look, let's click on one of these, and essentially I can see this is just a regular JSON file, but over on the side of the Explorer I can see that I have an outline tool which allows me to actually navigate through my infrastructure code, giving me a much better view of actually what the infrastructure code really is about. Now I can actually utilize this and navigate through by clicking on any one of these nodes, and I can see the JSON definitions that are important to me here. And I can also see that I can include things like extensions for my virtual machines, including I'd like to have the extension for Azure Diagnostics. We can define information about the network interfaces, what network we're going to actually connect to, should this be part of an availability set, and where are we going to store our virtual machines hard disks. So effectively everything about our infrastructure is sitting here in this single piece of code. Now I can also use Visual Studio to attempt to help me to actually deploy this. By right clicking on the project, I can simply go say deploy, and I'll get a wizard up asking me what subscription am I going to work on. So I'm going to say I want to work on my currently registered Azure Stack Guru. If I had additional subscriptions including public Azure, they would show up in here. In this case it's just my Azure Stack. I can see the subscription is my POC for Azure Stack, and I have the ability to create a brand new resource group, which we'll do for this particular project. So I'll call this one TechDays Online. And of course the Azure Stack has locales just like the public Azure, and in this case we only have the one, which is essentially called local by default. And then I can see the template and the parameters for the template. So before we deploy, we obviously need to answer some of the questions. So the first question is really, what is the admin name? And you can see these are also represented in the actual JSON as I look over in the JSON outline. So I'm just going to fill in these and how many virtual machines we'd like. So we'll save these in, and I should now be ready to deploy. Now this deployment follows exactly the same procedures as if I was deploying to public Azure, starting off a PowerShell module, which will essentially make an Azure or IM connection, and then push my JSON template and the parameters up for deployment to my stack. And if I switch over to my stack, I'll see shortly that this has actually begun its process of trying to deploy for us. The feedback is coming down here as well. Okay, now, while all that's going on, let's take a look at how we're going to actually add this to our continuous. I'm in my Visual Studio Online account, so I'm going to basically say I want to create a new project. I need to provide the project with a name, and I want to also make sure that the version control that I'm using is Git. Click Create Project, and then I'll wait a few moments as Visual Studio Online actually prepares the environment for me. Okay, fantastic. Now let's navigate over to the project. And there we go, we are ready to start. I'm going to dismiss this. Now let's get back as far as Visual Studio. Now back in Visual Studio, what we're going to do is highlight the solution, and this time we're going to add the solution code to our Git repository. So the first thing I need to do here is provide a small comment, and once I'm happy with that, I also need to configure, as he suggests, some settings in my configuration. So I'm going to provide a username and an email address. Now with those in place, I'm just going to update, switch my view down to the changes, and now I can commit. So now I can see the commit was created locally, and I'm going to sync those up to Visual Studio Online. Let's take another look at our Visual Studio Online. This time I'm going to switch over to the code view, and under the code view I should see a repository for TechDays 2016, and under here, if I expand it out, I'll see the templates and that Azure deploy JSON file which we created in Visual Studio a little bit earlier on. That's perfect. Our next stop is going to be on the build. Now in this case, the term build is a misnomer. We're not actually building any source. What we are going to do is create a zip file which is called an artifact, and we're going to use that to publish out as far as our release management, which is going to be the gate that we use then to communicate with our Azure environment. Now in the build screen, we're looking at all builds definitions, and as this is our first time here, we don't actually have a definition, so I'm going to hit the plus button, and I'm going to start on the process of creating a new, and in this particular case, empty build definition. Now this build definition is going to come from our project, so let's just check and make sure we have our TechDays repository, and we've only got one branch in that, so we're going to use that particular branch. And I'm also going to check the box which says continuous integration. So this essentially will cause a build to happen or a new artifact to be created every time that we actually push back up as far as the repository. So let's create that. In this build definition, we need to actually add a step. So we click the option to add a step. And we're going to select the utility option. And from the utility option, we're going to select the choice which says Publish Build Artifacts. Now we can close the add task, and on the Publish Artifacts we can actually start filling in some information. So the first thing we're going to do is we're going to click the ellipse or the three dots beside the path to publish, and we're going to expand down in our project the whole way down as far as our templates folder. And going to select OK on that. We need to give this a name. So we'll call this one TechDays Infrastructure as Code. And the artifact type we're going to set as server. And finally, we're going to click on the save name. He wants a name for the definition. So again, I'm just going to call this one TechDays 2016 and hit OK. Now I've got our first step in our build's definitions for TechDays 2016 in place. Right, now that we have defined our step, let's see how this works. Just going to click the button Queue Build. And I'm going to leave all of the settings as default and simply hit OK. Now we'll wait a moment for an agent to become available. And once the agent becomes available, we can see we're connected to the actual build controller. And we finally get all the steps through and we have a nice successful build of our artifacts. Now the last step that we need to focus on is the release process. So we're going to switch again in our Visual Studio Online environment over to the Release Management tab. And we're going to start off with a new definition. I'm going to start with an empty definition template and click Next. Going to turn on the option for continuous deployment and create. And at this point we are ready to start configuring the steps. I'm going to rename the environment from environment 1 to development. I'm going to check to make sure that the artifact is actually defined, and I can see that I have TechDays 2016 in place, and if I click on the link I can see that we have that already wired up as part of the initial step in the wizard. And let's take a look at the triggers to see when are we going to actually trigger this particular definition, and this is set again as we filled out the initial wizard to run as a continuous deployment against our project TechDays 2016. Now let's go back as far as the environment piece, and we can now go forward and add a task. Now this is going to control our actual deployment, and I'm going to select the option which is Azure Resource Group Deployment and click Add on it. And I'm going to close the wizard. Now here I'm going to start filling in some information about my resource configuration. If I look at the drop down, I have nothing available to me, so the first thing I'm going to do is click on Action. Now we've got to define the actual services and add a new service endpoint. The service endpoint essentially is going to connect directly to our Azure Resource Manager. And to do that, we need to actually provide it a name and some additional details. So in this particular case, I'm simply going to call this one our Azure POC. Now the details that's needed in here, we actually haven't yet provisioned. So let's go away and do that first. I'm going to open a new browser, and from that browser, I'm actually going to make a connection over as far as my Azure Active Directory instance. And with my credential provided, I should now be able to see the old classic Azure portal. It'll take a few moments to load. And take a look at that instance. From here, I'm going to go to the applications. And I can see in this directory already the applications that I own, which essentially are the trusts back to my Azure Stack environment. Now I'm going to add a new application. This is one that we would say my organization is developing. I'm going to call this one Visual Studio Online. And I can put anything in here. Now once that application has been added, we can come in and take a closer look at its properties. So if we click on the configure option, select a set of keys, period of time I want them to be valid for, and save. Once the keys are generated, we're going to actually see the key presented on the screen. This key is obviously very private, very secretive. It's only shown once, and normally you would never show this on a presentation, but after I finish this presentation, I will be destroying these keys. Just not that I don't trust you guys from hacking me, what? And I'm going to keep a copy of those locally just for sanity's sake. So let's take the client ID and go back to our Visual Studio Online. And in that field, I'm going to define that as the principal. And then let's take that secret key that we just had for our password. And we can put that one into the service principal name. Now, on our Azure Stack, we need to take some information. Okay, now we're back in our Azure Stack portal. I'm going to browse, and I'm going to take a look for a list of subscriptions. And here I should see the main subscription, which has a name, Azure Stack POC. And I want to actually get some additional information, which includes, of course, the subscription ID. So I'm going to copy the subscription ID. And again, going to bring that back as far as my Visual Studio and paste in the subscription ID. And I also need to cart over the actual subscription name. So click on that and copy it. And again, back to our Visual Studio, paste in that information. And then finally, the last piece of information I need to carry over is going to be my tenant ID, which in my case should be as simply Azure Stack Guru. Now I can store that down. And I now have information for my service endpoint. Now let's switch back as far as our configuration. We'll refresh. And then from the drop down, I should see my new endpoint. And this time I should be able to actually provide information for my resource groups. So I'm going to call this one again TechDays. And we'll hit the ellipse. And we're going to actually take our TechDays 2016 ISC template. Of course, we also need to provide the parameters. Or if I wanted to do overrides for any other environment, now I can provide that information here as well. Now I'm going to swing back as far as the main releases view. Going to do a refresh, and I can see that there's no release in place. So let's click the green button and let's create a release. It wants a quick description, so we're going to just test release. Again, we're looking for some information, so we're just going to call this version 1 and ask it to create. And that's it. Now essentially we have effectively kicked off the environment, and you can see there is some progress going on for the builds, and then that will move forward to the release environments. Well, there we have it. That is what it feels like to work to the Visual Studio take a look at the actual code that is effectively the new methodology of building infrastructure, how we would embrace and include that into our existing projects, work it through the build cycles, create those artifacts, and then of course start defining the release cycles, the targets, and where we want to actually have these environments built out. I hope you've enjoyed the presentation and it has introduced you to some of the brand new concepts of delivering infrastructure as code, what Microsoft are offering to us in 2016 through containers and through the Azure Stack solutions. And please feel free to reach out and keep those questions coming in on the Twitter and on the Q&A sections. And we're looking forward to helping and talking to you again. My name is Damien Flynn, and this has been a pleasure. Thank you. Bye bye.